So, picking up where we left off, last time all we really did was configure your project so it would acknowledge the various axes and to display the values when you're pressing left, right, up, down, or on the two trigger buttons. So basically, we really weren't utilizing those values. We weren't really applying those values to anything. We were simply displaying the value. So now we're going to actually start applying the value. This one we'll just look at changing speed, and then in the next one maybe we'll look at changing animation sequence. So let's go to game object, 3D object, we'll create a cube. Going to stretch it out a bit. See how that looks. Now what we'll do is we'll take another game object, 3D object, sphere, and we're going to make this a lot smaller so we have a lot of room to maneuver. And let's make that like 0.4, 0.4, 0.4. Also, let's change its color. Right click, create, material, just call it orb matte, and we'll just change that color. Just so it's easier to differentiate the two objects. And just drag and drop it. Alright, so now, slide this over, see how that looks. Actually, that's too far. That's better. And also, let's make this a little bit bigger. Alright, so that's enough setup. What we're going to do now is we're going to apply that float value, that +1 to -1, to the sphere. Now, to do that, we don't really want to change the sphere's position per se. What we want to do is we want to change velocity. In other words, how fast is it moving? So to do that, it needs a rigid body. So add component, physics, rigid body, and let's get rid of gravity. Now what we're going to do is now that it has a rigid body, we can make changes through a script. So right click, create, C#, and we'll call this move orb. So we'll click on the sphere. Actually, I'm just going to rename it orb because I keep saying orb anyways. So we got our orb. We added the rigid body. We added the orb matte. Now let's go ahead and add the move orb script. We'll open that up. Zoom in a bit. Now what we're going to do is in the update section, we're going to apply that value. Well, it's a little bit messy to see input.getAxes and then the name of the axes. So let's create a variable, dump it into the variable. So public, and we said it's a float. So public float, and we'll call this xvel ADJ. In other words, x velocity adjustment, because this isn't going to be the full velocity. This is only a portion of it, and I'll explain why in a minute. And it'll start at 0. So here's what we do. So in the update section, which runs once per frame, that new xvel ADJ is going to be equal to input.getAxes, and we said it was horizontal, and if there's a typo, it won't work. So every frame, the value of the horizontal axis is being dropped into this variable, and as we said, it ranges from +1 to -1. If it's at rest, it's 0. So now, get component, rigid body. Again, this script is attached to the orb. The orb has a rigid body, so to access that rigid body component, it's get component, rigid body, and it's velocity. And what we're going to do is we're just going to change x for now. Now, here's what I was saying. The reason why this isn't just called x velocity is because having a velocity of 1 to -1 is really quite slow. So you really want to multiply that by another number. So for the moment, we'll use a constant. We'll say 3, completely and utterly arbitrary. Oops, sorry. Velocity equals new vector 3. Got ahead of myself. And again, vector 3, x is an x, a y, and a z component. Well, I shouldn't say component, vector. So, so it's going to be, we said we're using the number 3 also. Could be 4, could be 5, could be 6, but 3 is a good number to use. So 3 times x vel adjustment, 0y, 0z velocity. So let's look at this. This starts off at 0, okay? So that means at first there is 0 velocity. Say you press this to the left. So you have -0.1, -0.2, -0.5, all the way up to -1. So that means this could be as little as like -0.3, -0.6. It could go as high as -3. Likewise, if this is going to the positive, then it's positive 0.3, positive 0.6, positive, 1.5. So that, I believe, should do it. So I'm going to move the controller to the left, and there we go. It moved. And then actually, even with that, it's moving pretty fast. But what we want to do is really want to demonstrate the fact that it has a range of speeds. So you can see it's just really 1. So let's press just a little. See how it's moving very slowly? And you can see the top number is 0.16. Now it's faster, faster, and even faster. So that's exactly what we were looking for, is to have a large enough range where you could really see the difference. And that one statement handles both the left and the right. Now, let's take the block and now scale it out along the z. So make it 5. That's not enough. 10. And now what we'll do, we'll have another variable. Public float y val adj. So hopefully you're seeing the pattern, and that is you're really going to do the same thing all over again, just for the y axes. Now, well, actually, let's call it z. Because what this is going to do is, if you're using the coordinates in the scene, up and down is y. So Unity may be referring to the up and down on the controller as the y-axis, but in this case, we're using it to move deeper, like it's the forward, tank control. To move it up moves you forward. So don't want to get confused. This is z in the world, but when you go back to the edit and input, that this is saying it's the y-axis. So don't want to get confused. Y-axis just means it's up and down on the controller, but in the world, it's the z-axis. So we'll put it right in here, and since we're saying we're changing the z, then we need to put it into the z axis. So we really just, it's rinse and repeat. We created an x, a variable for the x, inputted the axis into it, and then modified it here. So we've put in the z here, so we just need to copy this now. And so z val adjustment, and that one was called vertical. So again, you rinse and repeat. You got the variable, you got the corresponding input, and then the corresponding adjustment to a vector. You got the variable, corresponding input, corresponding change to a vector. And it's that easy to apply those raw numbers from the controller. So I'm going to press up on the controller now very slightly. Oh, that's right. Towards the screen is negative, away is positive. So sorry about that. So in this case, so really I guess we just reverse it. We'd do -3 then. So let's try that again. So I'm going to push up. There we go. We're moving in, pushing back, coming towards the screen. And so that easy, you now have, and as you can see, it can actually do multiple at once because they're not mutually exclusive. The only thing that this does, though, is since the value of the controller is being put right into the orb, it drops to 0 just about instantaneously. So if in your game, you'd probably actually have there be a little bit of a buffer. And we can explain in a later video how to do that. Yeah, so that should about do it for this video. And in the next video, maybe we'll actually have like we'll use like a 2D character and actually have different animation frames and animation sequences based on speed.